case study 7, as you can see here, we used a low quality background. Also, we created a pair of CG canvas shoes, seamlessly integrated this CG shoe into the low quality footage. During this process, we went through 3D camera tracking, 3D modeling, and creating textures, eventually render all the passes out for compositing. Because we are dealing with low-end footage, so during compositing, we also need to deal with those artifacts. For instance, black edges caused by heavy compressions. When you first time open these project files, you will see error messages here and there. The reason for that is because you have the files placed in a different location, which is different compared to mine. That is why your media files are disconnected. All you need to do is to double-click the arrow icon here. This is the original path. All you need to do is to go to the case study 7 CG shoe project and 7_01. That's the folder placed for this file, BJ original background plate. Open it. And the same thing for these files, double click it, then you can see the original path located in 706. 706, and that's the first file, FBX. Basically, they are sharing the same FBX file. Everything is properly loaded. Now let's get into the script. This is a 3D camera tracking script. Obviously, we need to denoise the plate. As you can see, the quality of this plate is already quite bad, not good at all. A JPEG, some heavily compressed artifacts, for instance, around the keyboard. Because this is a JPEG image, all the color information in the highlights is lost in the first place without any color information. And also we see some interesting chromatic aberration. These are not only caused by the compression, so we also need to simulate this effect in compositing. Because the denoise operation can be a bit heavy, so discache it. After that, lens distortion. I used a legacy lens distortion node. We don't have any information for this plate. We don't know cameras, lenses, and focal length, and so on and so forth. The only information I can say is from those edges of the table. We can see the barrel shape a little bit. So again, I used a legacy lens distortion node. We drew 2 lines along the edges of the table. If I temporarily hide the lines, the edges are getting straight before, after. Then after that, I used a roto node to roto the reflection. Even no moving elements in the scene, but it's still, highly reflected glasses or mirrors or things like that. It should be ideally masked out. So during 3D camera tracking, the nuke will ignore this white area. After 3D camera tracking, we eventually got a result like this. We also placed a couple of testing geometries. Then if we take a look at this, in the 3D scene. This is a handheld shot, that's why you can see the shaky camera. We don't see any drifting issues, that's a good sign. After the 3D camera tracking is finished, we also generated a basic 3D model using these 2 nodes. The first node is a point cloud generator, as you can see here, for visualization purposes. Then after that, we use Poisson mesh, eventually generate a basic 3D mesh. And again, it's rough, but we can see the basic positions. After that, we write out this mesh by using a right geo node, as you can see here. It's rendered as FBX. And also we calculated the overscan plate, which is this size. The original background plate size is Full HD. However, after the lens distortion, then eventually we calculated this final overscan size, which will be used for rendering 3D elements. And also the moving camera and tracking features are exported as well. Especially the camera is rendered out as FBX format for match moving purposes. Alright, this is the match move scene loaded in Maya. If I take a look at the camera first, you can see all the frames are embedded. In the outliner, we can say Nuke imported data. That's the new camera. When you first time get these locators imported into Maya, by default, it's set to 1 because the measurements between these two applications are different. That's obviously unworkable, so we reduce it to 0.02 for all these tracking features. We can also say this is the basic mesh we generated in Nuke. Now, as you can see here, this is a pair of shoes I created based on reference images captured on set. If we take a look at the reference images here at different camera angles, for instance, the front, top, back and side, use this as a reference image with a real-world scale, eventually built up the models in Maya. The next step is to deal with textures. I didn't go with procedural applications for creating textures. For demonstration purposes, I used the reference images captured on set for creating textures based on the final output aspect ratios. This is a comparison between the original reference image and after. For texture purposes. It's still work in progress at that moment, but all wrinkles were gradually removed. This is another reference we used in the book, and this is HDRI captured on set in this environment, and the 3D camera tracking with the meshes generated in Nuke, and the final test. When the models, everything's finished, I rendered traditional AOA passes in this project. For instance, the beauty pass, matte, diffuse, and specular, reflection, occlusion, ID passes, and motion vectors and shadows on the ground. Then eventually all those passes will be recombined and used in compositing. Let's take a look at this entire section, which includes multi-pass compositing, color correction, and also add chromatic aberrations and grading through ID passes, and also different bits and pieces down here. So the first section here is about multi-passes. We have rendered some key AOA passes, as we can see here. This is the diffuse no shadow and specular no shadow. If we use plus operations, we can combine them together. From the result, we can say before and after. The previous version has got diffuse color only. Now we added specular in. Then after that, the indirect path is added in by using a plus operation, especially if you say this area before and after. Then after that, use a difference, integrated the shadows into the CG passes. Then after that, reflection from the shoe itself is also added in by using a plus operation before after. Then after that is occlusion. Occlusion path is multiplied, then eventually we added those soft shadows. Alright, the color correction node here is to produce some artifacts for this CG shoe. Eventually, it can be seamlessly integrated into the live action footage. For instance, that is the original live action footage. Especially in the highlights, we can say they're all blown out. So we need to simulate this to the CG shoe. As you can see here, the CG shoe currently is looking correct. Nothing wrong with that, with proper color information in the highlights. To simulate the artifacts in the highlights of the original live action footage, we use two shuffle nodes to shuffle the B channel of the CG shoe into its alpha channel. And also the second shuffle node is to shuffle the red channel to its alpha channel. If we take a look at the alpha channel here, this is alpha. Now the B channel is shuffled into the alpha channel. And same thing, if we take a look at this one, the red channel is shuffled into the alpha channel of the CG shoe. Now we used two separate color grading nodes and connect the mask to the shuffle nodes here, 1, 2, to simulate that artifact. If we do a comparison before and after, we're literally color grading the shoe by using the B channel, which is shuffled into the alpha, and use alpha as a mask connection to create this blown out effect. then that is the first grade node. The second one, it adds even stronger effect. We did it twice, but using different channels. This one is blue channel, this one is red channel. Then after this artifact is created, the next section is to deal with chromatic aberration. We used two shuffle nodes. One is a combination of the red channel plus green channel. Another one is a blue channel. If I temporarily disable the transform, then after that we recombine these two separate channels by using a plus operation. We went back to the result produced here. These two results are currently identical. However, if we use a transform to transform the blue channel here, then shift to the position over slightly before and after, shifted. The size of this blue channel is slightly enlarged. Can we see? We produced this chromatic aberration effect. This section actually is to use these ID passes for further color grading. We can separate different portions of the shoe for specific color correction. For instance, this area piped into the mask input of the grade node. Now, until this stage, we're dealing a composition without alpha. Now, it is time to copy the matte of the shoes to the mainstream. Now, we used a copy node to copy the alpha channel of this matte directed to the alpha channel of this result. From now on, we are dealing with a pre-multiplied image. You want to be really careful if you want to apply color grading or apply the film grain and things like that. If we take a look at the original plate, for instance, the mouse black edge around the images here and there. To simulate this artifact, we used a sharper node here. Now you can see we are purposely creating those heavily compressed artifacts to the image. Now the image has got highlights blown out, chromatic aberrations added, and black edges, and also film grain. Now the final operation before integrating the CG shoot into the live action footage is to add a lens distortion. This lens distortion is extracted from the original live action footage. Before, after. Now it's ready for the final composition. That's the original background image with a shadow graded on the table. And also we have this CG shoe prepared. Now we can use a merge node to merge image A, which is the CG shoe, on top of the original background plate with a shadow graded on the table. We got this. That's the final result.